Ladies and gentlemen, dear colleagues, my name is Gyula Kovácsról. I'm from the Hungarian National Library and I am the head of the web archiving team. To be honest, I don't want to talk about the threats of AI. In the online world, what is such a title called? Clickbait. I have two reasons for this. First, I haven't met them in the library yet. But more importantly, this is because I have a clear answer to this question. For libraries, this is more of a chance than a threat. Therefore, my presentation will be about the integration of artificial intelligence into the services of the Hungarian National Library to illustrate through examples how AI gives us a chance. I don't think there is any need to define artificial intelligence today or to emphasize its importance. The latter is well illustrated by the fact that the International Federation of Library Associations and Institutions has set up a special interest group to look into AI issues. There are currently 3 projects underway, one of which is the development of a library strategic response to artificial intelligence. As part of this, the main areas where libraries can apply AI have been identified. 13 main areas are listed here, like AI to make collections, machine-readable data and describe them at scale, AI to enhance or create metadata, and so on and so forth. Many of these are already present in libraries, but most need improvement. And some applications are still to come. Let me describe the areas where AI is applied in the Hungarian National Library. These are marked in red. In some of them we have achieved significant results, and in some of them we are at the beginning of implementation. I have put these in brackets in the list. The blue arrows will indicate which of the areas identified by the IFLA we are developing. Automated cataloging and classification. Writing scripts for RPA purposes. RPA is robotic process automation. Named entity recognition. Handwritten text recognition. Automated OCR and HDR correction. Image reconstruction. Creating images, animations, and music for data visualizations. Creating data sets for researchers. For example, text for building large language models, and so on. The first area I will mention where we are applying AI is web archiving. You can learn more about our web archiving activities on our website, also in English. Please visit and learn. Web archiving creates a volume of content that is impossible to process by human labor. In the classification of the archive web content, state-of-the-art topic modeling is not enough, because standard library subject headings need to be assigned. Therefore, topic modeling should be adapted to the assignment of subject headings. Implementation of the NNIF system is under preparation in the National Széchenyi Library. NNIF is a tool for automated subject indexing and classification developed by the National Library of Finland. NNIF uses a combination of existing natural language processing and machine learning tools, and it's multilingual and can support any subject vocabulary. We are currently in the first two phases at the National Sechenyi Library. We are building the subject vocabulary based on our thesaurus, and we are preparing the training data corpus. The next area is the AI-supported scripting in the web archive. In web archiving, we can make good use of generative artificial intelligence for programming tasks. There are many tasks in web archiving that need to be automated. In many cases, small scripts are needed to perform these tasks without human intervention. And in our experience, generative AI can write these scripts quite well. Sometimes refinement, post-correction is necessary. An example, before our top domain level web harvest, we do that twice a year, we need to review the initial so-called seed URLs and fetch the title data of the sites to be harvested from their source code. If prompted correctly, generative AI can handle tasks like this. Here is an example here's a script written by the AI to extract the data of the websites from their source code. The next area is named entity recognition. Named entity recognition is a subtask of information extraction that seeks to locate and classify named entities mentioned in unstructured text into predefined categories such as person names, organizations, locations, medical codes, and so on and so forth. The National Sechenyi Library makes extensive use of this NLP technology in the creation of digital text editions, for example. The Emagyar text processing system, so-called EMTSV, is used. It has a named entity recognition module. In digital scholarly editions, this is how we mark, for example, personal names, which are highlighted in color in the reader window. And by hovering the mouse pointer over them, we can click on them and display the data in the various name databases, as you can see here. On this slide, you can see the workflow for the production of a digital scholarly edition of a manuscript. The starting point is the digitized manuscript. The next step is the handwritten text recognition, which is used to produce the digital text. I will talk about this in more detail later. The digital text is annotated with the TI XML and is then ready for publication. You can visit the dupla.hu site to check our digital scholarly editions. The whole system is versioned in Git. And now for the handwritten text recognition. HTR is the ability of a computer to receive and interpret intelligible handwritten input from sources such as paper documents, photographs, touchscreens, and other devices. The text of the digital editions produced in the National Sechenyi Library is converted from image to text using the AI-based Transcribus software. Transcribus is an AI-powered handwriting and text recognition technology to decipher both handwritten historical documents and printed text. How does it work? The first step is to mark the text area, the lines and the baseline of the lines on the image manually. This is carried out by human labor. In Transcribus, it's possible to teach models to recognize the handwriting. This is supervised machine learning. During the process, it's possible to gradually refine the model recognition capabilities due to human corrections. We have now several models. And finally, depending on the success of teaching the model, we obtain the transcribed text with varying degrees of error. Correcting errors manually still takes less time than a full transcription manually. The next area is automated OCR and HDR correction. We are in the first steps in this area. The next, the National Széchenyi Library digitizes millions of pages of documents every month, and post-processing requires support for AI, such as correcting OCR errors. The same applies to HDR, or breaking down digitized microfilms, microfiches of journals into volumes, for example. OCR software embedded with machine learning can be trained to recognize patterns and the meaning of content through a set of rules. This can be done through supervised learning, unsupervised learning, or combining these two training methods. The next area is creating data sets for researchers. One of the most important tasks of the National Library is to provide researchers with searchable data sets from its data resources. One of the most demanded data types today is high-quality text. For example, as I mentioned before, for building large language models. A workflow was developed in the National Széchenyi Library to build NLP-processed text corpora from archived web content to make it available for research purposes. A key part of the process is the so-called boilerplate removal, which means that the raw text is fetched from the HTML. We are using the Jan Homikalik's JAX-TEXT algorithm for this purpose. And using this method, we can offer researchers high-quality text from archived web content. And now for the conclusions. Libraries can use AI in countless areas, and this is set to grow. Collaboration is inevitable. The knowledge and data sets are not in one place. In addition, of course, financial resources are needed. Human resources, software and cloud services are not free. But perhaps most importantly, libraries need to identify the AI opportunities for their own tasks and develop in these directions. This is a chance. And please allow me to thank you for your attention with an AI-generated image. The prompt was artificial intelligence in the libraries. Thank you very much.